All right, so we'll look at one more simple example for a conservation of momentum problem that might not look like one at first. Okay, so let's say we have a sled and it's sitting on a block of ice. And let's say we have a cat that's on the sled. Okay? And then for some reason the cat sees something and he decides to jump off. With some velocity vc. All right, and now, so we want to find, so when the cat jumps off, the sled's going to move to the right with some velocity v sled. All right, so think about for a second before you continue in the video why we know the sled has to move to the, why the sled has to move to the left if the cat's jumping to the right. So the idea here, again, is we have a conservation of momentum. So our initial momentum is 0, right? The cat's just sitting on the sled, they're not moving. But our final momentum is going to be the mass of the cat times the velocity of the cat plus the mass of the sled times the velocity of the sled. And then again, we see that this is very simple to solve. The velocity of the sled is just minus the mass of the cat, the velocity of the cat, over the mass of the sled. And so, we see that the velocity is in the opposite direction as the cat, which we would expect because, in order for the cat to gain momentum to travel to the right, that means it also has to give some of its momentum to the sled, which is going to push the sled to the left. So this is exactly what we would expect.